Hello, this is our Elec 327 final project, and we are Gerald Liu, Kairong Xu, and Oscar Zhang. To introduce our project, our concept is similar to a music synthesizer. We were inspired by how it could respond to physical input and output something and could mix multiple inputs for multiple sounds. For example, if you press a C and an E, you'll get something that's different than just a C or an E. We decided to implement this with a microcontroller and the digital to analog converter. And we also decided that we would be communicating with I2C communication. Below is a basic block diagram of what our system does. Our system first takes in physical input, and then through the configured GPIO of the microcontroller is able to read what is going on and then output the respective data to the DAC, and the DAC then converts it into an analog waveform, which takes it to an amplifier, which prepares the signal ready to be played by the speaker.
The system is built around the MSPM0 microcontroller. We used I2C protocol to communicate between the microcontroller and the DAC module. The microcontroller sends computed digital waves to the DAC. The DAC then outputs an analog voltage waveform to the amplifier to amplify the audio. Each button is connected to a GPIO pin on the microcontroller with an internal pull-down resistor to detect rising edge inputs. When the button is pressed, the power voltage is connected to the corresponding GPIO pin. The microcontroller computes the digital waves and output the signal via SDA to the DAC. We also added an active low LED to indicate the stage of the microcontroller we're in. We also added capacitors to prevent power noise near the microcontroller. For the software part, we used an example provided by the Texas Instruments to configure the GPIO and I2C and timing function. We used active high logic and inverse our LED pin for that. We also configured the pin mux for each pin so that it is correctly set up for its functionality.
And now after we did all of that, we programmed it, and our code architecture is mainly based around how each button interacts with the frequency. So to start off our code file, we first initialize our GPIO pins and all our pins for I2C via TI's own library function with sysconfig. And then we create a bunch of booleans next to that, a bunch of booleans for the buttons to detect whether or not the button is being pressed, and then under that logic we have the corresponding frequency with a constant we defined earlier. Once we get to that, we then send the corresponding waveform to the DAC via I2C communication, and here's where you can look at this DAC write function. We make sure that we first check the controller status is idle before we send the data to the DAC, and make sure that the line clears after. We modulate what we send by changing the period of the write time through those half period delays we instantiated earlier, and this also allows for frequency mixing. For conclusion, we were able to get sound through the speaker, but it was very, very tiny and difficult to hear. And we think that this is because we might not have used the correct amplifier that is compatible with a speaker and microcontroller, and we think that would help us see our project results better. We also had a bit of trouble with the storage function we were originally going to implement, because SRAM on chip is volatile memory, which means once we turn it off, there will be no storage anymore. So we're also exploring ways to get that memory to be constantly stored, maybe through a low power mode we talked about in class. And this concludes our Elec 327 final project presentation.